So I'll just start off with a short video.
And here we go.
Time to package some dead fish.
Oh yeah, this is really challenging.
All right. It might not be the most exciting job in the world, but at least it'll earn us enough money to get Mom and Dad some new furniture. Hey, grab that one, grab that one. Dude, grab it. I got it, don't worry. Whoa, this thing's going kind of fast. Hey, can you slow it down a little bit?
Whoa, hey, grab the pieces.
Grab them. Put them on the side,
I'm trying.
Don't go through.
Dude, they stick.
Yes!
Oh, she's coming back. Hurry.
Excellent. You boys are doing a fine job. Speed it up a little!
And here we go.
So why did I show you this video? Although we don't work on an assembly line or packaging sushi, but we are building workflows, and workflows can get overwhelmed by traffic, and it's pretty similar to what we saw. So I want to discuss here on how we can handle this. So let's start with some history. So at first we had monoliths, which were just big services that had all of the logic inside. They were managing the orchestration layers as well as the logic itself. We went on to SOA architecture, where we broke down the monolith a little bit, but it still had a lot of dependencies. And then we went on to microservices. In microservices, each part is independent, it's more scalable, it has less risk in each change, but what is still left? So when we take a monolith and want to break it down, or we just plan a new microservice system, we have multiple features. So let's say, like in this example, we have on one side, we have a monolith where all the features are implemented inside with one single database. So if we want to turn that into microservices, we'd usually break it down into some services where each one has features, has a database, but we're left with the orchestration logic outside of it. So because each service should do some function. So how do we solve that? That's the question that is left. So there are many ways to orchestrate workflows. I just showed here a couple of options. We can orchestrate using queues. So for example, some functions can put items into a queue, others will dequeue it and proceed it to the next queue. There are options to use databases for orchestrations, but all of those are just custom and they have their own problems. Each service needs to know where the orchestration layer is coming from. It needs to know where to in-queue and dequeue items from. So there are different solutions like we want to discuss today. So let's have step functions to the rescue. So what do step functions do? It actually, the idea of it is to take some services, some functions, and turn them into an app. So just orchestrating all of this logic into one place. So what actually is it for me as a developer? First of all, it will keep you sleeping at night. You only focus on what you do best. You develop your business logic, and you can rest assured that the orchestration layer will not fail. It will keep working, and you don't need to worry about that. It saves a lot of development time because it's really, really easy to create this workflow and just to attach services to each other. And the deployment and management of the infrastructure is built into AWS. So which use cases can step function help us solve? I've listed a couple of here. So first thing we have is the long asynchronous jobs. It can run up to 1 year, and things like media transcoding, machine learning, or ETL jobs are a very good match for this. We have the short synchronous jobs. It can be also async, but it's um, it's the same pattern. For example, like e-commerce, like checking out or doing things like that. And we have the live jobs. For example, authentication, when it needs to run very, very fast. So if we take a look at the previous example and see how we can create this using step functions. So we see our microservices here, and the orchestration layer itself is implemented on the step function. Step function doesn't hold any of the logic of, of your services. It just decides when and how to call them. So we'll have here the flow itself, and the implementation will be implemented on Lambda function, ECS services, or anything else. So what do you get from the resiliency point of view? It's an AWS managed service. So everything that's coming from it is a given. It has a high uptime. It's 99.9%. That's what the official documentation says. It's really, really up. It doesn't fail. It doesn't lose state. So even if something stops in the middle, you can always continue from that point. You will know where your application stopped. And it has built-in error and timeout handling. So from the point of view of service integrations, AWS services are just first-class citizens here. So things like Lambda function, SQS and SNS, DynamoDB, API gateway, batch, or anything else that you can think of that is built into AWS, it's really, really easy to integrate. I just put in one example here on the side, just calling an API gateway invoke. That's it, and you're calling your API gateway. So some of the key features I think here is of generic workflow. So for example, forking and joining flows, we can do parallel execution. Some patterns like async callback is a really great thing to do in many cases. For example, if we want to do manual intervention in the middle of a flow, we can, for example, send a message to some service. The workflow will stop and wait until you return a message to an SQS. So you can do manual intervention and then continue from the point where you stopped. You don't need to split your flows because you need manual intervention in the middle. One more nice thing that you can do here is select the flow based on the data itself. So let's take an example. If you want to do some manipulation on a file, if we have a very small file, we can decide to run on a Lambda function. But if we have a very large file, we can decide to run on an EC2 instance. So this is something that can be easily done here. So let's talk about some key concepts. So we have, first of all, we have the state machine. State machine is the workflow itself. It's written in ASL, which is Amazon's state language. The next important thing is the task state. The task state is the actual steps in the workflow. It represents a single logical unit of work. It doesn't actually do any work. It's a representation of calling some service to perform the actual work. So the execution state is where we store the data that is being passed between the steps. So we can pass data from one result to another input. It can be referenced by a $sign. We have the context. The context is actually the metadata information about the state machine itself and the execution. So things like the execution ARN or the input or the formations, the history, or anything you want to do to know that is not the data itself that is passing resides here. So another important thing to understand about step function and how it works is how the input and output is being processed. So each task state is being passed on into the entire execution state. So what it does is, first of all, it takes the input path and selects which part of the state we want to take. Next part, we take the parameters, which is just a definition in a different way of how the input of that service looks like. It takes the output and put it through result selector, which is selecting a part of the result of the service, passes it on to the result path, which is selecting where do we want to put this result in, and the output is just deciding on how the state will look like after it's completed. So I'd just like to show you a quick example of how this works. So so here's on the step functions, there is a nice data flow simulator that can show you and help you create and debug the workflow of a step. So for example, we can set here the state input. So just give it some data and it goes to the input path. The input path is defined like this. So if I don't put here anything, it will just pass on the entire state. I can filter it out and it takes part of it. The parameter part is just defining the object that will be used as an input for the task itself. So here we can put on static values and we can take on, for example, a part of the input that was filtered in the previous state. And this will be the final result that will be passed into the service. So next we define the output of the task. So put here some dummy data. And then we do the result selector. Result selector is actually taking a part of the result of the task and putting it somewhere. So here I define a response user. So it takes part of the result and creates an object. So after that was set, we have the result path. The result path is taking the state that was before we started the task and putting the result on top of it. So also here, if we don't put anything or just $, it will replace everything. If we set something, it will be appended to the existing result. And the last part will be the output path. The output path is just deciding how the entire state looks like and what is being stored. It's a kind of a filter. So again, if we don't set anything, it will just take everything and put it onto the path. We can filter and take only the response, for example, from this function. And then the next step will just show us how the state will look like. So I'd just like to show you just an example of something that I prepared for this. So this is the state machines that we've defined. We can see here the definition. So for this, I just used a type that's called path. A path is just a dummy for input and output. It doesn't actually do any processing. It can help us manipulate data. But here, for example, it can be calling some Lambda function or an API gateway or anything else. So this is how a flow looks like, a DSL and a visualization of the flow itself. So after that, if we go into some execution, we can see that it ran, it's all green, so it all passed. And we can see the execution input, what it got, and the execution output. So here, for example, on every step, we've appended the result of each step. So the final output will look like that. So one more nice thing that I want to show you here is how we can take and look at the logs of the execution in CloudWatch. So everything, it's just a definition on creating the step function. It can all be sent into CloudWatch log group. So we can take here on insights, for example, and just check what happened. So each step is sending the entire data. So we can see here the execution error in itself. We can see the role that was executing, and we can see the data that was in there. So this is really nice and easy to just get an overview of what happened in the state machine itself. So it doesn't include the logs for the service that performs the actual execution. We can also, if you are writing to CloudWatch, so you can also view it here, but this is the execution of the state machine itself. And this data, for example, can be streamed from here into things like Athena or anything like that, so we can view and see all of our data in one place. And then we can run, just analytics on it or anything else that we want. So for a few examples here on what we can do with step function. So for example, like we said, there is an asynchronous callback through SQS. So here we just define some queue, we send a message and wait on another queue for the state machine to continue. So it will actually get paused, wait for the message to arrive on that queue and continue. Another sample is calling API gateway. So as we said here, it's pretty simple. We just say API gateway invoke. We pass it all the parameters. We say what endpoint, what method, what data we want to pass there. For example, here you can see an example of how a result selector will look like, and continue from there. And another thing I wanted to show here is an iteration example. So an iteration is actually just a for loop. So we can take some data, all the data for the iteration is residing on the context, and we can do a map, index, and value, and create any logic that we want inside the iteration. So for example, here I've added an example of how to put a DynamoDB put item. So that's all you need to put an item into a DynamoDB and do an iteration. So you just select the table name, the item, and that's it. You can just write there, and then you can do the same things for reading from Dynamo, deleting, or any other operation. And the one last thing that I wanted to cover is our working group. So this is the way that we work in Chegg. We create working groups for technologies and try to define what are the best ways to use it and how to work with it. So for step functions, what we are doing is providing a decision tree. The reason for it is when someone wants to create a workflow and it has some use case, we want it to be a place where someone can come and look at the use case and understand if step function has good support for it. We like to define things like best practices and guidelines. So for example, how do we do DLQs? So there are ways how to do it right, how to do retries, how do we create, for example, a circuit breaker inside the workflow. There are patterns for that, and we want to decide how to do it best. So for that, for example, there is an example on how to write it to DynamoDB and read it before some steps to decide if we want to continue or not. So that way we create a circuit breaker that is shared across all instances and all executions. And of course, just creating some templates for code on how we can consume actions from step functions, and how do we do the deployments using Terraform. And when we look at the code and what we want to do in there is that every service shouldn't even understand or be aware of that he's being called from step functions, because the functions are really just logic. So the orchestration layer itself will reside on the workflow, and the logic will reside on the service. So for example, the DLQ will be part of the step function, but running the execution will be on the service. And that's it. So if you have any questions, I'll be happy to answer.
Hi, Gil. There is a question on the chat from Ankit. Can a step function invoke another step function?
Yeah, so that's possible like any other AWS service. It's a built-in integration. We can split our workflows between many workflows. We can create some logical units that can be reused. If we have a flow that can be reused from other flows. So yeah, it's really easy. The only thing to consider when doing that is that the cost of step function is defined by the amount of state transitions. So every time we wrap something in another transition, it's more cost to it, although the cost is really low.
There's one more question. What do you think of concurrency when we use step function?
Yeah. So concurrency is pretty much built in, and I think that most of it should be defined outside the state machine itself, because state machine should define things like, do we want, can in the single workflow we can do parallel executions. When we do concurrency, it should be defined, for example, on the service itself. So if we have a Lambda that, for example, is talking to some third-party vendor, and we have a rate limiting on how much requests we can do. So this limiting should be done on this service and not on the workflow itself, because other workflows can call the same service, and the service can perform multiple actions. So the workflow itself should just say that we're calling the service, and if there are no available executions left, so it will just wait until there are available lambdas, for example.
Thanks, Phil. Do we have time for any other questions? Ankit?
Yeah, we do have some time if there are any questions.
And please feel free to raise your hand or type your question in chat or in Q&A.
All right, if there's no further questions, then I think we can put a wrap on it. I just want to start by thanking all of the Chegg participants who have taken their time to prepare the presentations and give these out to everybody. You guys did a great job. Thank you for that. I want to thank all the other participants who've joined us and asked some good questions and given us some other interesting things to think about. Please continue to do that as a follow-up. Fill out the survey and let us know. I mean, this is our first time ever doing this, so we would love to hear from you. What you'd like to see from us in the future. Spencer mentioned early on we're going to do something for the UI side of the house. This one today was more about services. So if there's something that you guys would like to see there, or next time we do a services one, how can we make it better for you? So let us know. Other than that, we hope to see you in the industry. Feel free to connect to us on LinkedIn or wherever else you guys like to do it. So with that, I think we can adjourn. Any last thoughts or comments from anybody? All right. So until next time, then, I think we're done. Thank you all.